हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार। फ्रेंड्स, आइए स्टार्ट करते हैं दिस टॉपिक, डिजायरेबल प्रॉपर्टीज ऑफ रेफ्रिजरेंट। फ्रेंड्स, व्हाट आर द प्रॉपर्टीज इज देयर which define the performance of the refrigerant? So it can be categorized in three categories: in thermodynamic properties, chemical properties, and physical properties. Friends, what happened? Main function of the refrigerant is that it can take heat or absorb heat at low temperature and pressure, and it can reject heat at higher pressure and higher temperature. Getting friends? So what happened? What are the properties required for this? So it is related to heat. So thermodynamic properties is important. Chemical properties is also important, and physical properties also important. So we will see one by one, friends. Like here you see thermodynamic properties. Like here, friends, the critical temperature of the refrigerant, enthalpy of the vaporization, conductivity, COP, specific heat. So these all are the parameters which will define the refrigerant. Okay, friends. So let's understand what is the critical temperature of the refrigerant. Friends, critical temperature of the refrigerant, it should be as high as possible. Why? Because friends, if low critical temperature is there, it means what happened? The liquid will not condense, because how much pressure you give above the critical pressure, refrigerant will not condense. But we know that the properties of the refrigerant is that it will evaporate, it will come in the vapor form, then it will reject heat and come in the liquid form. But above the critical temperature, it will not condense. Like example, like CO2, its critical temperature is 31.5 degrees centigrade. So friends, as you see in our environment, like temperature is 40 degrees centigrade, 45 degrees centigrade is there. So how we can use this one? Because above 31.5 degrees centigrade, the CO2 will come in the vapor form, and what happened? It will not condense. How much pressure you give, it will not condense. So it is not recommended. If suppose any gas is there, if its temperature is equal to 100 degrees centigrade, yeah, 150 degrees centigrade, so what happened? Below this, it will condense, it will evaporate, and it will work according to our performance. Getting friends? So critical temperature should be as high as possible. Okay. Enthalpy of vaporization. Enthalpy of vaporization should be large. What is the meaning of enthalpy, friends? Enthalpy is the heat addition at constant pressure. Okay. So what happened? It should be large so that it can absorb more and more heat. Okay. If enthalpy is of vaporization should be large so that it can absorb more and more heat from the system. Okay. So it should be large. Conductivity should be as high as possible. So because of this, the heat transfer will be more and more. Okay. So suppose here heat transfer is there, this is the pipe, and above some fluid is there, here refrigerant is there. So what happened? It will transfer heat more and more. So thermal conductivity of the refrigerant should be high as possible. COP, coefficient of performance, decide the running cost. So if larger COP is there, small cost will be there. So we know that friends, we have to give lower cost and achieve more profit. So COP should be larger so that our cost will be reduced. Specific heat, specific of the liquid must be small. So if refrigerant in the liquid state, then in this case specific heat should be small. But specific heat of the vapor must be large. Getting friends? Now pressure ratio. Pressure ratio means friends, like here this is the TS diagram of vapor compression refrigeration cycle. So this is the evaporator pressure. This is the 1 2 3 and 4. So this is the evaporator pressure, this is the condenser pressure. So this is the condenser pressure, this is the evaporator pressure. Okay. So friends, it should be as small as possible, because if you increase, then what happen? If you increase pressure ratio, then what happen? Work input will increase. So what happen? Refrigeration effect also decrease. So what happened? Because of this, pressure ratio should be as small as possible. So smaller pressure ratio desirable. Freezing point of the liquid as low as possible. Suppose our refrigerant freezing point is minus 5 degrees centigrade, but the system is working at minus 10 degrees centigrade or minus 15 degrees centigrade. So what happened? Our refrigerant will not work. So our refrigerant should be below this one. So it should be minus 20 degrees centigrade or minus 30 degrees centigrade, so that it will work in this situation. So freezing point should be as low as possible. Getting friends? Freezing point should be as low as possible. The specific volume at the inlet of the compressor should be small, so that what happened? Smaller volume is there, so that it can easily compress the vapor. So specific volume of the refrigerant should be small. Now compressor discharge temperature should not be very high. It should be required. Suppose what happened friends, if this is the evaporator pressure, this is the condenser. So if compressor discharge temperature is this much, then what happened? We have to give more and more work. Okay. So and also it is required more heat transfer. Suppose it is like this here, in this case smaller work done is there and heat is also required to remove less compared to this one earlier. So what happened? This is the compressor outlet temperature. Here this is the compressor outlet temperature. So compressor outlet temperature, a discharge temperature should not be very high. Boiling point must be low. Why? Because boiling point is low, so that it can take easily heat and come in the vapor form. Okay. So a small amount of heat is required to evaporate the refrigerant. Getting friends? So these all are the properties of thermodynamic properties. Now we will see chemical properties. Chemical properties means refrigerant we are using, it should not be toxic. If toxicity is there, means what happen? It will be dangerous for the human being. Suppose any leakage is there, so toxicity, it will get problem. Flammable, it should not be flammable. Jwalansheel, suppose any spark is there, it will catch the fire. So chemically should be inflammable, chemically should be intoxic or non-toxic. Action with oil. So what happened friends? Some refrigerant is there. In compressor, we are using the oil, so that proper and smooth performance will be there. But what happened? Refrigerant, some refrigerant is there. It will act on the oil and mix with that. Some refrigerant, what happened? Purely mix with that and it will be the part of the refrigerant. We can say some refrigerant mix with oil and oil become the part of the refrigerant. It will not create a problem because it will rotate with the refrigerant in the circuit. Other type is there. Some refrigerant is that it will react with the oil, but it will not mix. It will not mix. Then what happen? we will put oil separator and the refrigerant will fully flow in the circuit. But what happened, friends? The refrigerant partially mixed with the oil, or we can say oil partially mixed with the refrigerant. So what happened, friends? It will create the problem in the circuit. It will mix with the refrigerant and it will go to the other part of the compressor and deposit the oil. So it will choke problem will be there. So other problems will be there. So action with oil is also important. Now these all are the chemical properties. Then physical properties like viscosity should be low so that easily it can flow. Leak detection should be there. Suppose any leakage is there, we can easily detect the refrigerant. It should not be, we can say corrosive. Corrosive should not be there. So we can add one more point so that it should not be corrosive to the corrosive with the parts. So what happened? A refrigerant is there. It corrode the pipes. Something like some refrigerant should not be suitable for copper. Some refrigerant should not be suitable for aluminum. So based on that we can see. Getting, friends? So these all are the properties of the refrigerant which is required while using and is required to perform well. Our performance will be depend on the properties of the refrigerant. Getting, friends? Hope you like. सो फ्रेंड्स, आपको मेरा एक्सप्लेनेशन अच्छा लगे तो प्लीज़ लाइक कीजिए, कमेंट कीजिए। आपको किसी भी पॉइंट पर डाउट हो फ्रेंड्स, आप मुझे कमेंट बॉक्स में पूछ सकते हैं, मैं उसको रिप्लाई करने की पूरी कोशिश करूंगा फ्रेंड्स। मेरे चैनल को सब्सक्राइब कीजिए, दोस्तों के साथ शेयर कीजिए फ्रेंड्स। थैंक यू।